Good day, my dear listeners. Welcome to today's lesson on integration and differentiation. But first, let us look at a little revision on differentiation before we get into what we have in mind. So let's take one or two examples on differentiation, then we'll come back to integration and we'll see the relationship between differentiation and integration. So let's look at this example. If you're told if y is equal to 4x cubed, I told find dy dx. In other words, we are saying differentiate y with respect to x. So for us to do that, we will say, let's go back to our general differentiation formula, which you know that is the y dx now is equal to nx to the power of n minus 1. Here, where n here is the coefficient of this x cube, and this 3 here, this n here again, is the power of what we are differentiating, which in this case is 3. So this 3 now will come over here and multiply this 4. And then it will also drop by 1. What am I saying? If we have here that our dy dx here will now be 3 multiplying 4 gives us 12. Then x to the power of your 3 we drop by 1, which we have as 12x to the power of 3 minus 1 is what? 2. Let's take another example. If you are given if y is equal to 4x squared plus 3x minus 5, and you're told find dy dx. So that means differentiate y with respect to x. Here, what do I do? Again, we have this is derivative of a sum. We can handle this individually. So I can differentiate 4x squared plus, I will now differentiate 3x, and then differentiating a constant gives you 0. So here I will have that dy dx will now be 2 times 4 gives me what? 8x, then my power 2 minus 1, then plus 3x. This 3, why I just wrote 3 is because this is 1, then 1 multiplying 3 gives me 3, then 1 minus 1. And when you differentiate 5, it gives you 0. So here we now have our dy dx now gives us 8x. This is 2 minus 1 is 1, so plus 3. 1 minus 1 is 0. So which finally we have that our dy dx now gives us 8x plus 3. Okay, now let's bring up integration, and you see clearly why I will tell you that differentiation is a reverse of integration. In other words, differentiation can be said to be the opposite of integration. Let's use this example to prove that. Let me clean the side and we'll talk about that. Now, integration. Now, our integration, if we have the integration, this is the formula here. If you're told integrate 12x squared dx. Remember, I said we differentiated this one to get this. So if we integrate this, we are meant to get this back. So let's find out. But first, let's look at the formula for integration. Integration says 1 divided by n plus 1, then x to the power of n plus 1, then plus c. This c is a constant here, which is supposed to have been any number that would have been here, which is a constant like 2, 3, 4, 5, 6, which you know when you integrate or when you differentiate them, it gives you 0. So those values here means little or nothing, but we just know that there is a constant there. So whatever we're going to differentiate, after that, just like when I have plus 0 here, you know that whatever, or plus 3 here, you know that whatever I do here, it will still round off to 0. That is why we had to include the c there. Okay, now let's look at it. For us to now differentiate this one, the integration of this, first, how do we do this? If you want to integrate and you have a constant here first, you shift that constant to the front of the integration and you differentiate, you integrate this one as it is. So what am I saying? We have, this will now give us 12, the integration of x squared dx. So I now have 12 now multiplying, I now bringing out my formula, which is 1 over, what is my power? 2 plus 1. Then x to the power of 2 plus 1. Then plus c, which I will go ahead to have 12 now multiplying 1 over 2 plus 1 gives me what? 3. Then I have x to the power of 3 plus c, which I can cancel out here. 3 can go here, 1, 3 will go here, 4. So what I'm going to have in essence, we have that this will now give us 4 multiplying x will give us 4x to the power of 3 plus c. So, which you can see from here, we are back to the original thing that we had. Let's take more examples. Now, assuming we are told evaluate the integration of 3x to the power of 4 plus 2x squared minus 5 dx. How do we handle this? Remember, just as we did in this initial part here, where I said when you have a constant here to integrate, just shift it and bring it in front of the integration sign. Now, what it means is that if I'm going to solve this one, I will have 3 moving over here, the same thing 2 also, and the same thing 5 also. So I can differentiate this one separately, just as I talked about derivative of a sum, where you can differentiate individually, you can equally integrate individually. So I can integrate this one to become 3, the integration of x to the power of 4, then plus 2, the integration of x squared, minus 5, the integration of x to the power of 0 dx. Why did I put to the power of 0? You know that whatever you raise up to the power of 0 is still 1. So it is the same thing I'm talking about. This is the same thing as 5. I did not change any value. So here we now have, this will be 3 now multiplying. This will now give us 1 over n here in this case is what? 4. So we have 4 plus 1, then x to the power of 4 plus 1, then plus 2 multiplying 1 over 2 plus 1 x to the power of 2 plus 1, then minus 5 multiplying 1 over, this is 0, remember, 0 plus 1. Let's clean up this side so we'll have, so this will give us 0 plus 1 x to the power of 0 plus 1, then plus c. All right, so here what are we going to do? We have 3 multiplying 1 over 5 x to the power of 5, then plus have 2 multiplying 1 over 3 x to the power of 3 minus 5 times 1 over 1 x to the power of 1 plus c, which when we multiply further, we have 5 multiplying all this will give us 5, sorry, this give us 3 all divided by 5 x to the power of 5 plus 2 over 3 x to the power of 3, then minus 5 x to the power of 1 if you like, then plus c, and you have integrated. Let's take another example. We can look, okay, I should have copied this. Let's clean this up and pick another example. Now, let's look at this here. If you are told to evaluate the integration of the square root of x all raised to power 2 dx, or let's put it raised to power 3. Now we know that anything square root means raised to power half if you want to relate it with indices. So I can rearrange this one to be the integration of x to the power of half, then bracket 3 dx, which, you know, in indices I can open up this bracket to give me the integration of x to the power of 3 over 2 dx. Okay, which I can now solve as 1 over, this one now becomes 3 over 2, so we have 3 over 2 plus 1, then x to the power of 3 over 2 plus 1, then plus c, which again, 3 over 2 plus 1, if we are to solve, 3 over 2 means 1.5, so 1.5 plus 1 gives me what? 2.5. So 2.5, we have 1 divided by 2.5, which is 5 over 2. Then we have x to the power of, again, 5 over 2, then plus c. And you know that we can, if you have a double bracket this way, you can overturn. That means I can rearrange this one to become 1 over 1, if you like, divided by 5 over 2, then x to the power of 5 over 2 plus c, which I can have 1 over 1 times 2 over 5 x to the power of 5 over 2 plus c, which I now have 2 over 5 x to the power of 5 over 2 plus c. So I have integrated again. Let's take further examples and see. Let's take one more, which again I can say integrate 4, or let's use another number. They're told integrate 2x to the power of 4 plus 3x cubed minus 5x squared plus 3 dx. So with this, I can go ahead to do the same thing I did before, which is bringing 2 outside, the integration of x to the power of 4, plus bringing 3 outside, the integration of x to the power of 3, minus bringing 5 outside, the integration of x squared, then plus 3, the integration of x to the power of 0, then I have the x, which again, I can proceed to have 2 multiplying 1 over 4 plus 1, then x to the power of 4 plus 1, then plus 3 multiplying 1 over 3 plus 1, then x to the power of 3 plus 1, then minus 5 multiplying 1 over 2 plus 1, x to the power of 2 plus 1, then plus 3 multiplying 1 over 0 plus 1, x to the power of 0 plus 1, or plus c. Okay, so let's clean this so that we don't get confused. Okay, so here I have 2 now multiplying 1 over 5 x to the power of 5 plus this 3 multiplying 1 over 4 x to the power of 4 minus 5 multiplying 1 over 3 x to the power of 3, then plus 3 multiplying 1 over 1 x to the power of 1 plus c, which we can proceed and solve. 2 multiplying this gives us 2 over 5 x to the power of 5 plus 3 over 4 x to the power of 4 minus 5 over 3 x to the power of 3, then plus 3x to the power of 1, if you like, then plus c, and you have further integrated. Okay. All right, I think we're going to stop here, and in my next video, we are going to see some more integrations, maybe on a little more complex note. Till then, have a nice time, and see you again.